Let us take a look at Azure DevOps Repos. So from our dashboard, we can navigate to repos. And when we do that, we will land on this page with the default repo already created. So we'll always end up with a default repository for the project that we are in. Now, because Azure DevOps supports our DevOps ambitions, where we may have a single repository for all the development, or we might end up with a microservices architecture type of application where we need multiple repositories for the multiple projects that are involved, then we can actually have multiple repos. So if I click this drop down up top, then I can go to new repository, import repository, or even manage repositories. Manage repositories allows me to manage the list of repositories, and you'll see that you have a default one, which if I click the ellipsis, I would get the option to delete, but I cannot because it has to be there as the default option. However, you can always create a new one, and we are going to look at the steps to create a new one and how we can use it, and we'll continue that in the next lesson. Now let us go back to our repos tab, and like we just discovered, there are several ways to go ahead and create a new repository. So we can actually, from this section, click the drop down up here, click new repository, or we can go to manage repositories, which gives us the option to once again create. From here, however, I'll just go ahead and click new repository, and then this brings up a side menu which allows me to specify a name. So I'm going to call this School Management Web. Notice that Git is already selected and it is the default option that is available to us. And we have the option to add a README and then a Git ignore file. Right now it says none, but I'm going to go ahead and I'm going to look through this list. Now the Git ignore file is a file that specifies to a repository that when you are tracking our source code files, you can ignore certain files. And this goes a long way in helping us to ignore personal files or different build files that are more unique to our computer and don't necessarily need to be in the repository for the rest of the team. There are preset values that we can select, and they are all based on the types of projects that we might end up building. This is a very comprehensive list, and I suggest that you use this list, or at least use one of these templates when you're starting off on a particular type of project, so that you can make sure that you have at least the foundation right. But this file is editable. In this course, we're going to be using Visual Studio Code or .NET projects. So I can just type in here and I'll see Visual Studio. So I'm going to go ahead and select this Git ignore file template. And then it says that the repository will be initialized to a main branch. Let us go ahead and click create. Here we just created our very first repository. Now remember that you can have multiple repositories within this project. So I can actually repeat those steps as many times as I need to. And from this dropdown, I can switch between the different branches. So if I repeat these steps and create another repository, I'll just call this one test. And I'll leave out the git ignore and hit create. Then I get another one. It's called test. And I can switch between them all. Now I can always go to manage repositories, and I can remove the one that I don't want. At this point, if you are the team lead or the administrator for the organization, you want to consider putting in proper permissions to make sure that not everyone can actually carry out these actions. To see what permissions are possible, you can always go over to security and you'll see the user permissions and the different groups. And as you assign users to each group, you can dictate what each group can do. So be very sure that you explore these options and that you enable and disable the correct permissions based on the groups and based on your users. However, let me proceed to remove this repository. So I'll go ahead and delete test, and then I need to confirm by typing in the name, and then I can hit delete, and there we have it. Now that we have created our very first repository, let us in the next lesson see how we can configure Git on our machine and use Visual Studio Code. In this lesson, we're going to install and configure Git and Visual Studio Code, and we will take a look at the Git credential helper, which allows us to securely store our Git credentials and communicate with Azure DevOps. Now, for this course, we have a few prerequisites. Number one is Visual Studio Code. Now, I'm going to be using Visual Studio Code to carry out the demos. That being said, if you have another IDE that you are comfortable with that also has Git tools, then you may use that. But for this lesson, I'm going to be focusing on how we can facilitate integration using Visual Studio Code. I'm also going to be demoing using a .NET project. But since Git, Visual Studio Code, and Azure DevOps Repos are all platform and technology agnostic, if you have another framework that you want to follow along with, maybe a Node project or React or Angular, etc., then feel free to use the programming framework and language that you are more comfortable with. The overall steps of integrating with source control will be invariably the same. Now, I did mention that we are going to be integrating with Git. So if you don't already have Git on your machine, I would suggest that you go ahead and download it. So you can go to git-scm.com/download, and that will bring you to this website where you can download any version that is applicable to your machine. So I'm on Windows. I'll go ahead and download for Windows. The installation process is fairly straightforward, so you can just go ahead and install it and give it a few. Now with Git installed, let us launch our command prompt or terminal, whichever one is applicable based on the machine that you are using. Now what we want to do is configure our Git credential manager. The first command that we're going to put in is git config --global and then credential.helper --win_cred. This declares to our machine that we're about to configure our Git global credential helper. The next command that you're going to put in is git config, once again, --global user.name, and then you're going to specify your name. So where you see John Doe as my placeholder, you go ahead and put your name. Then repeating this command, or at least not removing all of it, we can now say user.email and then specify your email address. And then of course, this is the email that you are currently using to authenticate against Azure DevOps. So you can go ahead and configure that email address. Now you may proceed to launch your IDE. Once again, in this situation, we're going to be using Visual Studio Code together. Most IDEs come with Git tools built in, or you can download plugins. And one of the first options that you would see with the Git plugins is the ability to clone a Git repository. Now in Visual Studio Code, on a fresh window, you will see that option available to you here. And if you click the source control icon to the left, you will see that option available as well. And even if you go to the Explorer, you're going to see that option. So there are a number of ways that you can initiate this process. So let us go ahead and click any one of them, and then they ask us to provide a repository URL or pick a repository source. Now, I already have GitHub integrated with my Visual Studio Code, which is why I'm seeing this option. You might not see that option, but that is not a problem. Now, to get this URL, what we need to do is go back over to Azure DevOps. And from here, we're going to click clone. And then this gives us the information that we need. So I could actually, from here, say clone in VS Code or select my IDE, just to show you how integrated and agnostic this tool is. So I could actually just go ahead and say clone in VS Code, which would initiate the process for me. But I've already gotten this far. So what I'm going to do is copy this URL. And what we're doing here is a global procedure for cloning down from a Git repository that is hosted, meaning that the fact that we have a Git repository with a URL, whether we're using GitHub, Azure DevOps, or Bitbucket, or any of the other popular Git providers, once we have this URL and we have an interface that allows us to clone our repository, we can just paste that URL there and press enter, navigate to the place where we know we want to clone to, and then we can select as repository destination. Once we do that, now in the middle of the process, you might be asked to confirm your. But once all of those steps are completed, then they'll say, would you like to open the cloned repository? So I'm going to click open, and Visual Studio Code will refresh itself and now start showing me the files that have been cloned down from the remote repository. So this means that if I came onto a project after the fact, the project was already in progress, people were already doing development, there were code files up there, and now I wanted to start getting my hands dirty. This is all I need to do to now make a local copy of the files on my computer and then start interacting with them. Here's that git ignore file that was generated for us. And once again, this is just a template that allows us to ignore certain temporary files that may be associated with a Visual Studio project, a .NET project, etc. So you can look through this. You can even just look at the patterns and extend this file if you have been adding other files that you want to be ignored. We also have access to the README, which uses this markup language called Markdown, ironically, and this allows us to properly document our project. So what we're going to do here, or what I'm going to do, and you can follow along with your framework of choice, but I'm going to go ahead and add some project files to this repository, and then we're going to go ahead and commit those files back to the source control. So we will do that in the next lesson. So what we're going to do in this lesson is start adding some files to our repository and then do a commit and look at how that whole process works. So let us start off in Visual Studio Code with a terminal window. You can open up a regular terminal or however it is that you would go ahead and add your kind of framework. But once again, I'm going to be using .NET. So you need to have the .NET SDK installed. I'm using .NET 7. At least at the time of recording, this was the latest and greatest version. So you can go ahead and set up that environment and follow along, or just use any framework of your choice. To launch a terminal window in Visual Studio Code, I can hold down on Control and press the tilde button, or I can just click Terminal up top and create new terminal. From here, I'm just going to use the .NET new CLI command, and I'm going to create a web API, something nice and simple, and then press enter, give it a few seconds. And then we have added our framework project to our repository. Now, if you notice, there are certain things that will stand out to you. One, at least I'm using the dark theme. So the color coding in the dark theme is such that my new files are color coded as green. If you look to the right, you'll also see that the letter U is very prominent. Now, this U means untracked, which means that Git is seeing that, hey, these are files that I did not have prior knowledge of. So you want to make sure that I know about them when you're about to check them in or commit them. We also can notice that some of the directories like OBJ, it's kind of grayed out. And if I expand that, you'll see that there are certain things in here that are grayed out. They're not green. They're not indicating that they're included. And that is because of the presence of the git ignore. So like we said, the git ignore is going to help us to avoid certain files that are temporary and not absolutely needed for the runtime or for the longevity of the project. Now we're going to look at different ways that we can go ahead and commit our changes. We're going to look at using the CLI, and we're going to look at some of the allowances that our UI gives us and certain things that we need to consider. So first off, when I want to now have all of these files tracked and then committed to my source control, and I just cleared my terminal, but I'm also just going to switch my terminal. So if I'm going to stay in Visual Studio Code to use the terminal, I'm going to want to switch over to the Git bash. So as many command line tools as you have installed, you can access them right here inside of Visual Studio without having to switch between Visual Studio Code without needing to switch between the windows. I'm going to go ahead and switch the terminal to Git bash. And if you prefer to use your regular terminal, you may do so without any consequence. Now, what I want us to do is use the git commands to 1, track all of the untracked files, 2, do a commit, and 3, push. These are commands that are very important for you to know. But if you are not interested in learning them and mastering the Git commands, you do have the option of using the visual tools, which usually come integrated into the IDE and are made available through other third-party options like GitHub Desktop or SourceTree, or there are several other options. Now, in our Git bash, the first thing that I want to do is write the command git add and full stop. What this will do is say, look in the current directory and add everything to being tracked. When I press enter, then, well, there's no physical evidence of anything happening. But then the next thing I want to do is a commit. So the commit is the action of me making note of the fact that I have made a change. And remember, when we were looking at some of the best practices with source control management system, we always want to make sure that we write a nice message, right? So I'm going to say git commit and then state added web API files, right? Not an essay, but not vague. And then I can press enter, and I'm sorry, I'm going to have to retype that message and that command, and I forgot the -m. So this is the parameter to say git commit with this message. So let's try that again. And there it says that it has added these to the commit. So now it has tracked the fact that, okay, these new files have been added to the source control. Now, all of this happened locally, and that's what it means when we say Git is a distributed source control management system, because I did a commit, but this is to my machine. This is on the repository on my machine. Azure DevOps does not know about these files, or whatever remote repository does not know about these files right now. So getting the files into source control is usually a two-step process. We have to commit, like we just did, and then the next thing is that we have to do a git push. So when we clone a repository, and I'm just giving you the background so that we can understand all of these moving parts, and this is global to Git. When you clone a repository, what you do is you create what we call a remote. And then this remote usually by default will have the name origin. So this remote represents the connection to the remote repository, and it is possible to have multiple remotes. So we could actually be working on one Git repository on our machine, but synchronizing with several remote repositories, maybe one in GitHub, one in Azure DevOps, one elsewhere. I'm not sure why you would necessarily want to do it that way, but I'm just showing you the possibilities. So the next step here is to push from our machine to the remote repository. Note as well that we can have multiple commits in between. So it doesn't have to be that we commit and then push every single time. We can have several commits, which would happen locally. And then when we do a push, it will actually synchronize that history between all of our local commits and the remote repository. Now to execute the push, all I have to say is git push origin. And this will automatically connect to our repository through that remote, which is called origin by default. And you'll see here that it is communicating with that repository through that URL. Now, as a final act of validation, let's jump back over to Azure DevOps, where in the repository, it looks the same way we left it. But if I refresh this page, now I'm going to see that it has come to life with all of those files from my machine. And you'll see you can easily track what the commit message was, who committed these files, and at what point in time or in history they were committed. So that's how we can move files from our machine to our remote repository. So we've seen how one developer can make changes and contribute code changes to the remote repository. What we have not seen is how that developer will receive changes from the remote repository when other persons might be making changes. So that's what we want to simulate in this lesson. I'm not going to go too in depth because I don't really have many users that I can play around with, but we can actually use Azure DevOps to simulate changes happening right here in the remote repository. That's relatively easy because we can hover over a file, go to more options, and edit the file right here. So I'm just going to pick on the README a bit more, and I'm going to modify this file a bit more. And I'm just going to add another sentence under this, beside this introduction, where I'm saying we are validating that Git is an awesome SCM tool, just enough to make sure that we have a change. The procedure is relatively the same. We go to commit, and then we have the comment, and I'm not going to change that comment, but you can see it's there by default. We have always said that we should always link work items. So we'll get around to that later on in the course, but for now, just recall that we should always link work items to our commits, and we do have the option to do that here. I'm going to skip that for now, however, and click commit. So what we just simulated is a change happening by somebody else and being submitted to our source control management system or remote Git repository. Now, how do we compensate for that change back in our IDE? So every IDE that has Git integration allows you to do what we call a pull. Now, Visual Studio Code comes with additional options from commit, and if you click the ellipsis up here, you'll see that you have more actions, one of which is pull. Another one is fetch. So if I click fetch, what fetch does is it reaches out to the remote repository and asks, are there any changes? Are there any pending commits that I need to be aware of? Or rather, do you have anything that is different from what I have? So there are no real indicators. There's an indicator down here that will show you that, okay, there is one commit to pull. You can also go up here and change your views. And I can't show you every single thing. My advice is just experiment and explore with your IDE, because some IDEs may have these displays and some don't. So if I click source control repositories, it will actually show me a little tab here that shows me the name of the source control repository, the type, the branch that is being worked on, and then if there is anything to pull or push. I can also choose to commit from here, refresh, etc. And this is indicating that I have one pending change. However, all of those things are nice, but what I really want to do is pull. So when I click pull, it will go ahead, connect, and then it will synchronize the changes. And then now my README is going to show me the updated files. So that is, generally speaking, how we can go ahead and fetch the changes that are on the server. And that is essentially what happens. That pull operation is what happens. Once again, if we do a commit and sync, it will do the pull in the background. If there are no errors, meaning there are no conflicts between files and everything is good, then it will automatically update our version of the files with the commit history that it needs to know about, and then it will push our commit over. So that is really how you can go about retrieving the changes that have happened on the remote server. Now, in the next lesson, we're going to take a look at branch policies and how we can go about protecting our main branch from unwanted code changes. So we're back in Azure DevOps, and in this exercise, we're going to add a policy to the main branch to only allow changes through pull requests, and we will ensure that changes are reviewed before they are merged. So let us jump over to the branches tab under repos, and from here we can see all the branches that we have, but we only have main. So let us go ahead and hit the ellipsis and then go down to branch policies. Now from here, we have a number of iterations of permissions that we can put in to make sure that we have a workflow that works for our team. So one of those things that I would want to implement is to require a minimum number of reviewers. Now, of course, based on the size of your team and the layout of your team, this number will vary. So if I click this and turn it on, then I can change the minimum number of reviewers, and I'm going to put this to 1. And then I can say allow requesters to approve their own changes. Now, of course, what works for your team? So if you want to enforce code reviews, meaning you want at least 2 persons to look at the code, what we call the 4 eyes principle, then you would not want to allow requesters to approve their own changes. However, for our demo, I will allow this because I'm the only user here. Another thing that we can do is enforce that we have linked work items. So remember that we could previously go ahead and commit our code without linking the work item, but it's best practice to do that. So just in case you have people who might not be team players, then we can go ahead and make it required. Now, there are several other policies that you can enforce, such as enforcing that there must be build validation before the pull request can be merged. We can do status checks, and we can automatically include reviewers, such as maybe the lead and senior developers. However, with these changes made, we have implemented at least a branch policy that protects direct changes against the main branch. Now, let me test that out quickly. And this is going to be a quick and easy test because we did this before, where I was able to, from the editor, modify the README. So I'm going to say this is an edit since the policy. All right, so I've now done that. I can click commit, as we know we could. This is the main branch. Then I click commit, and then I'm now going to get this error. Pushes to this branch are not permitted. You must use a pull request to update this branch. So we have effectively and quite simply protected our main branch from anybody who might think that, okay, let me try and experiment on this code base. And of course, we all want to experiment, but what we don't want to do is do it against the main branch, which is always supposed to be production/deployment ready. Now, when we come back, we're going to revisit the concept of creating a branch, and then later on, we'll look at how we do a pull request. The last time we were here, we protected our main branch. So that means that no developer is allowed to put new code into the main branch. Now that begs the question, how exactly will we accept changes? And that answer is through branches and pull requests. So I'm going to switch back over to our project in Visual Studio Code, and this would simulate what we will go through in a real scenario where we have to work with a protected main branch and we need to make code changes. So from Visual Studio, I can create a new branch. So in this window, I'm going to look to the lower left-hand corner and I'm going to see main. When I click that, I have the option, and let me enlarge this a bit. We have the option to create a new branch from. So I'm going to go ahead and say create a new branch from. The reason I'm doing from is that it's now going to show me all of the potential sources from which I can create a new branch. Of course, I want this branch to be a direct copy of main, because what happens is when I'm doing a new feature, I need to develop this feature against the latest code, right? We keep on talking about that. So I want to base my branch on the main branch. So it's going to take a copy of the main branch. I'm going to give it a name. I'm going to call it dev-test. And then press enter to confirm. And now I am on the dev-test branch. Now I have my branch and I can do with it as I please. I can experiment. I can go ahead and complete my task. Whatever it is that led me to creating this copy, I am now allowed to do. So let me make a quick edit to the README. We keep on picking on the README file, and I'm just saying testing out this branch stuff. So with that change, notice that everything now is within the context of dev/test. So I'm going to say updated README and say testing branching, just so we're clear, because we've updated README quite a few times now. And then when I do a commit and push, note that this is going to the dev test branch. So it's going to say the branch dev test has no remote branch. What does that mean? Remember that everything happens on our machine first. So dev-test existed on my machine. Now I want to push it. It's saying that, well, there's no such branch by this name in Azure DevOps. Would you like to publish it? I say, okay. And after a few seconds, I can jump back over to Azure DevOps. And we're still here with the heartbreaking message that we cannot commit. But if I cancel this and then jump back over to branches, and yes, I will leave this page because I have nothing to save, then what do we see here? We see our dev-test branch. And of course, we can always flip between the main branch and my branches dev-test. So it is quite possible that every developer can have their own branch that we can't see based on our roles in the system. And in between, we would have to merge into main to make sure that everybody's up to date. So at this point, you see that my commit has been made to this new branch. However, if I jump over to main, it does not have that commit history at all on the README. Another place that you can see commits would be the commits section. And once again, you can always jump between the different branches to see the different commits. Now, the presence of a new branch with new commits will present us with this new option called a pull request, or PR for short. Now, from the branches menu, I can see it. From the files section, I can also see it. Once I'm on that dev test branch, it will say, hey, you made an update here that long ago. Do you want to create a pull request? So this means I can continue to work in my branch for, as many days and as many hours as it takes for me to work in the branch. But once I want to actually put my changes into main, I need to create this thing called a pull request. So if I click create a pull request, I get this new menu where it is saying that, okay, you want to merge from dev test into main, which means you want to put whatever is different about dev test into main. This is a very important process because there are times when we might have deleted something, overwritten a file, or made a mistake. This is like a nice buffer between the changes I have made and the changes that would be made in main if they are approved. If they're not approved, then they can't be made. You can add your title. You can put in the description of whatever work has been done. You can add your reviewers, of course. So I can add myself there. And we can even link the work item here. I'm just going to say document architecture as the work item. And we have the option of adding tags. Now, from this menu, I can also review the files that will be added. So here I'm adding this controller that I wasn't quite finished with, but okay. And I'm adding the changes to the README. I can also see all the commits that I made. Now remember, commits are local until they're pushed. So that means once I'm doing a pull request, all of the local commits that I might have done on my branch will now be available for viewing by the reviewer. So at this point, I can go ahead and create, or I can just save it as draft, but I'll go ahead and create. Now, the next menu that appears is what the reviewer or reviewers would see. So the reviewers would be able to check and see that, all of the pre-checks have been successful, and based on the number of checks that you have, you will see them. So later on, when we're looking at the build pipelines, we'll see how we can integrate that into these pre-checks. We can look at the files that are being checked in and review all the changes. We can look at all of the commit history and all of those things. So this is what the reviewer sees. If you see something that doesn't quite fit you, or you're not quite comfortable with, you can always leave a comment at this point, right? You can also leave direct comments on the exact line of code. So I could just say here, do not return default, right? And the developer will get this notification and be warned that, or at least alerted rather, that this comment has been left. And then we can have that cycled, this feedback loop that we always talk about in DevOps, until I can say resolved. So I can say good to go. All right, and it is resolved. So that is how a pull request works. Now, at the end of all of this, I can approve with suggestions, wait for author, meaning maybe I left feedback, so I'm waiting on you to get back to me, or just reject it because something else went wrong. I can also ask for more reviewers to come and give an eye. I can associate more work items in case there was more work, and I can set up some form of auto completion as well. So I'm just going to go ahead and approve, and I'll approve and save comments. And now that it's approved, it will mark it that one reviewer approved. So until all the minimum number of reviewers have approved, then this step would not change, and we would not get the complete step. So that autocomplete would have happened upon the threshold being met of all of these checkboxes being marked positively. But without that, we still have to go back and complete it manually. That's fine. So we can just click complete, and then we can click save. And then we have several kinds of merge types available to us. So we have merge with no fast forward. This means that we merge with a nonlinear history and preserve all commits. So that means every single commit that was made against your own branch will now be merged into the commit history of the main branch. We also have squash commit, which means that a linear history that will combine all source commits into a single commit on the target. And basically, it will just squash everything into one commit. So if you made 20 commits, it's at the time of the merge that we're just going to make one commit and one message to say we have merged at this PR. Without going into too much detail about all of them, I'm just going to go ahead with merge, no fast forward, and then go ahead and complete the merge. Now we can go back to files, and when we review our README, we see here that it has the commit from our own branch and it has the change. So now we have introduced a nice quality gate to make sure that the code that makes it to the main branch is of the topmost quality based on the standards of the team. This was an exciting section, and I hope you feel so as well. What we did in this section was we embarked on exploring the Azure DevOps Repos allowances. We started off by creating our first repository. We added some default files like a git ignore and a readme file. And then we looked at using other tools to help us to manage this development process afterwards. So we went and got Visual Studio Code or any other IDE that you are comfortable with, and we got our Git installed to our system. Once we had those installed, we used the Git credentials manager to make sure that we could establish a connection between our local machine and our remote repository. And then what we did was we cloned this remote repository to our local machine and then started working. This work had us pushing changes, pulling changes, interacting with the remote repository, all from our own machine. And during that process, we saw where it is dangerous to be able to directly submit new code into what we call the main branch, which is the branch that should always be production or release ready. So we went ahead and added what we call branch policies to make sure that nobody can just push code to our main branch, but you have to have what we call a pull request, and upon approval, then we can merge all of that.